All right, hello and welcome. Here we go with another episode on containers from the couch. I'm really excited about our episode today, talking about eBPF and how it relates to observability with Kubernetes. Yes, I know eBPF, definitely a buzzword, but I hope by the end of this episode, we show you how eBPF is more than just a buzzword and how observability is actually one of the more unique and perfect, quite frankly, use cases for eBPF. I've got two awesome guests here with me today. First, I'll start with Nirmal, Mehta, Principal Solutions Architect at AWS. Nirmal, tell us a little bit about what you do day to day at AWS and why observability is important to you.
Yeah, so thank you, Sai. Thanks for having me, and I'm excited to get into this topic today. So, why does observability matter? Is a great question. Well, as our CTO famously said, Werner Vogel's, everything fails all the time. That's like a core architectural principle, I guess, or component of how we design our systems at AWS and how we talk to customers about their own solutions and their own architectures and how they should be designed. And if our customers are designing their systems properly, they'll be able to handle when that inevitable failure happens at any level of the stack. And in order to know if something failed, you have to observe it, right? You have to monitor it and be able to react. So fundamentally, observability is around understanding what the state of a system is and being able to respond and dig into whatever is going on in that system. If the health of that system is not performing the way you intend, or there's a failure, how are you going to figure out where that failure is and resolve the issue? So observability is kind of foundational to any good architecture. It's a core pillar under operational excellence and the other well-architected pillars that we have at AWS. And again, it's just foundational. So with respect to Kubernetes, there's a little bit of a twist, right? Kubernetes is this other layer on top of like the typical kind of infrastructure components: networking, storage, compute. This Kubernetes layer has additional insight in orchestrating these resources. And so there's an extra layer of the system that we need to observe. And then your applications are deployed on top of, for example, EKS. And those themselves have entities or metadata or assets that we need to track and understand. And all of that has to be correlated for you to be able to respond if something fails or something is not performing the way you expected. So that's the extra twist with respect to Kubernetes and EKS that kind of sets the foundation for why observability is important. You want to make sure that you're delivering the best to your customers, to your end users, and observing how the system is working to support your users at every layer is foundational.
Excellent. Nirmal, so excited to have you on today. I love that quote from Werner, by the way. And what is Murphy's Law exactly? How does it go? It's anything that can go wrong will go wrong.
Yeah.
Love it. And for our guest of the hour here, Shahar Azulay, CEO and co-founder of groundcover. Shahar, so excited to have you on today. Tell us a little bit about how you landed in the space that groundcover is in, what led to creating groundcover, and what does the name mean? What does groundcover mean? How did you come up with that?
First, great to be here. Thanks for having me, and great reunited with Nirmal after our great talk at KubeCon. So thank you for having me here again. So basically, I mean, landing in observability in some senses is very straightforward to, I think, me and the core founding team of groundcover. On the one hand, it's like, the famous story of us being the users of ourselves in a state of things, because basically we've been using observability. We've been in the shoes of these users for years, battling against open source stacks, vendors, and whatever we needed to do to just get the job done as engineers and engineer managers. So I mean, the pull to there comes from, a lot of years in experience of just using these products and knowing how mission critical they are inside an organization. And I think, from a founder perspective, it just touches on these points of solving a really mission critical problem, and also a beautiful engineering problem, because observability is basically one of the most or difficult data problems on earth. And combine that with the fact that users use it to actually day to day to actually solve problems and eventually potentially getting a relief of the product you're building, and enjoying it and telling to their friends and maybe taking it to their next job. That's kind of what drove us to try kind of figure out groundcover. And the name comes from what we're trying to do. Basically, groundcover is an English word, although it sounds like it's two names combined to one, which basically describe a family of plants that cover the cracks, usually between pavements that are kind of built out with different stones on the ground. That's basically what we're trying to do with eBPF, which we'll talk about later. Basically, covering production or infrastructure end to end without leaving any cracks, and trying to create that feeling of everything is healthy, which is perhaps the nature analogy of that. So yeah, happy to be here.
Got it. And living here in Austin, Texas, by the way, grass is quickly becoming out of fashion just with how hot it is. And so I've seen that. There's a lot more lawns that I see which are just like ground cover, which is beautiful. Love it.
Yes. Great for the pollinators.
Absolutely. Shahar, by the way, your mic was cutting out just a little bit there, but you were sounding good at the end. But hey, my next question, Shahar, is actually to you. Today we're talking about eBPF. Before we ever get into, do you guys hear a little bit of background noise there? Okay, I think we're good now. Before we get into ground cover and exactly what it does, I think for our audience, it's going to be critical just to understand the value of eBPF specifically in the space of observability. And there's this crazy diagram that I always see being brought up whenever eBPF is brought up. This one right here. What is this? And how is this eBPF?
Yeah. So I think that I usually get asked about eBPF and kind of should we know eBPF, right? And that's I think in a sense eBPF is transitioning into a place where maybe other technologies have already moved into. This is kind of the internals of eBPF, how it's powered, where can it actually hook and touch and eventually allow you to visualize or observe. But for most of us, eBPF will stay far higher level than this diagram in its use cases, in the tools that we can kind of use to basically create a tool chain of solutions that eventually help us in our day to day. But since it's open source and very hype, I think that a lot of people still expect to perhaps being able to program eBPF or use that in their day-to-day life. Totally encourage that. I'm just saying that it's a bit hard. It's like writing your own SDK. You're probably going to use OpenTelemetry or something else in your actual day-to-day life, even though you might want to explore it. So eBPF has endless possibilities, and I think it's about kind of figuring out what you actually need to help solve the problem. And it's a very interesting toolkit, I'd say, of a lot of hooks that were in that picture that allow you to visualize and observe a lot of different parts of the infrastructure and the application, which is a very unique ability, which we utilize at groundcover.
Okay, excellent. So I've heard outlandish claims of what people can do with eBPF. Writing entire web applications in eBPF, and let's be honest, there might be a lot of use cases there. And I love that you said, encourage you to do it. But for something like observability, a lot of times it comes down to operational overhead. How much does the customer have to manage versus how much the cloud is managing for you? In this case, obviously AWS. And I know that we have a large spectrum of solutions here to help customers handle observability-based use cases. I know in many ways AWS can be opinionated here, but also we fully support open source cloud-native technologies. Nirmal, how does a customer navigate the number of tools out there today when wanting to set up observability, especially when you consider there's metrics and traces and logs and so many different aspects to it?
Yeah, that's a great question, and as solution architects side, we get that question a lot from our customers, and navigating the array of observability tools can be kind of tough for our customers. But let's take a step back. The best one of the better approaches to take is to think about working backwards from what matters to your end customer. So if you're deploying an application on EKS and that's providing some kind of like e-commerce front end or some kind of system that your customers are interacting with, taking a step back and thinking about what matters to them, in terms of what should you be monitoring, that's the actual thing that matters to them. Is it the latency of your application? Is it how many items they have in a shopping cart? Is it how fast they can log in? You have to determine that and then work backwards to figure out what metrics, traces, logs, what kind of observability telemetry data support those metrics and those indicators of the performance of your system or what matters. And then once you figure that out, then identify the tools that can support providing those signals. And that allows you to kind of narrow in already in terms of like an observability strategy for your system and figure out exactly what's important. Because at the end of the day, these architectures, they produce a lot of telemetry. And if you just collect it all, you're going to have to like navigate all that data to figure out what matters. And so starting with the working backwards from what matters gets you thinking in a more proactive state. So that's one kind of goal that we see a lot of our customers try to get to. Oftentimes, initially, systems and operators are in a reactive state, right? An alarm it gets sent off, or there's some kind of failure, and you're reacting to that. And ideally, we'd like to get our customers into a proactive state where the system is already detecting anomalies before some major failure, and potentially even allowing you to automatically react to it in the future. And with respect to containers and Kubernetes and EKS, working backwards is really important because of the different layers, right? You have the infrastructure, then you have the Kubernetes layer, and then you have your application. And that's where we have managed services and open source solutions, open source managed solutions that kind of cover those different layers of the infrastructure and different types of telemetry types. So we have CloudWatch logs and CloudWatch Container Insights for capturing metrics and traces and logs. And then we also have Amazon managed open source solutions that provide, like, for example, Prometheus metrics. And really we're not super opinionated about one way or another, because really it comes down to what your needs are for the application and the customers you're supporting. And with respect to groundcover, the eBPF based solution, open telemetry based, that's the kind of integration point with our Amazon observability services that allows our customers to really hone in on what's important and find that metric and that telemetry that helps them respond to a failure and maybe get to a proactive state.
Excellent. By the way, folks that are watching at home, we do have an in-depth demo coming up here very shortly. But Nirmal, I want to touch on what you said and connect it back up to our conversation with eBPF and groundcover. I truly believe what groundcover is doing is refreshingly new in the space of observability for a few different reasons. But I want to ask you a little bit of a loaded question here to kind of guide you in this direction, Shahar. Is eBPF the death of sidecar containers?
Well, we have a blog titled like that, so I guess I can't go back from that. But I definitely think it's a groundbreaking technology in the sense that it will do move a lot of technologies to be a bit different or complemented differently. So I wouldn't say the death of sidecars in total, but sidecars do have an inherent trade-off regarding performance and overhead, which we're all aware of, right? The reason we went for it is because it also introduces simplicity and easy integration and stuff like that. I think the eBPF has a lot of advantages, and as it evolves, I think it will push sidecars aside in some applications, and in some other cases, you would still use them in complement to eBPF. but definitely specifically in service meshes and things related to security policies and networking. We already see it being being more and more prominent, and for good reasons. We're talking about Kubernetes clusters that Nirmal mentioned. These scale up to be huge sizes and with very high API-driven networking behavior, using sidecars in a high volume of networking and pods being deployed. Isn't always that smart for the customer's infrastructure, and eBPF provides a significant ability to do kind of performance improvements as well as providing the job that needs to be done. So yeah, I do see it impacting a lot.
I want you to dive in on one thing that you mentioned is kind of that ease of use, the installation that just eBPF helps streamline and automate a little bit. Yeah. Why? How does eBPF make it easier to install observability tools? We mentioned sidecars, but also generally these tools require agents. Where does eBPF fit in here?
So in a sense, eBPF is a bit more tied into the infrastructure than other technologies, which in a sense, we're kind of going back, right? We started from infrastructure agents and exporters and things like that. And eventually we moved up into sidecars and SDKs, trying to stay closer to the container, the runtime, and the actual code. And again, for good reasons, trying to get more intimate, more context aware from the application, more context aware from the actual, workload being deployed, right? If you're running Kubernetes workload with a few different pods, but it introduced overhead and complexity as time passed. And now we're kind of going back into an agent, right? It's still eventually, in a sense, an agent, just more lightweight and more tied to the actual operating system that can do all that from a perspective of the actual operating system underneath. So when you look at Kubernetes, I think the problem just got worse with all the tools we had before, because we had 1,000 pods running on a specific huge node. And then, sidecars or collecting things with SDKs started to create something which was maybe unproportional to what you originally intend to do. And if you can do all that from one single infrastructure agent that can just observe all of them at once, that's an advantage. And I think that eBPF kind of allows us to take a step back and maybe run, a single agent per infrastructure host, and then kind of break out a bit from the Kubernetes, abstraction, right? Back into the origins of the actual infrastructure, but still stay very connected to the context, which is, if you lose that, you're back to a much worse state. So I think preserving the context of whatever you see on top, right? All these containers running on top of their application, giving you deep context, but yet running a single agent on each infrastructure host provides a really strong advantage, both in performance, but also now in simplicity. Basically, in Kubernetes, it means deploying a daemon set. That's it, right? No runtime changes, no integration with your actual deployments. We're not trying to say change your deployment, just introduce that flag in your Java deployment or whatever. It kind of brings you back into a cleaner state, which fits the Kubernetes mindset of modules running alongside one another and not necessarily tightly integrated and aware of each other, I'd say.
Yeah. One thing that you just mentioned there, Shahar, is context. What does that mean to what does that mean to you, and what does that mean to our customers when you say the word context within this stack?
So I think that over time, when we look 15 years back, maybe where modern NPM started, then they were very context aware because they built the entire stack, right? They built the agent to collect the data, the processing, and the actual backend, right, to store all that. Over time, we became infrastructure agnostic, right? Just send me your logs, just send me your OpenTelemetry traces, just send me your metrics. And because the customer's infrastructure was so diverse, right? I can run EC2s and ECS and some Lambdas and maybe a few EKS clusters on my Kubernetes, on my AWS environment. And the vendors offered us to be agnostic, right, to the infrastructure. Wherever these logs are coming from, I'll be able to present them, or whatever these metrics are coming from. And in Kubernetes, you mentioned it before, Nirmal, I think that context, knowing what the infrastructure is doing, because it's so complex and not that transparent, right? In a sense that a pod might be evicted, a node might be capacitated, right, and eventually kind of taken away from application. There could be interdependencies between applications. So if you ignore that context and stay infrastructure agnostic, you get the value of collecting data from anywhere. But in heavy Kubernetes environments, you lose a lot of context from the infrastructure, which might cause troubleshooting to be very, very, very complex because you're kind of losing the entire ability to understand, oh, that affected that, and that is the chain reaction that caused my application to slow down. eBPF allows you to kind of stay very grounded to the infrastructure, and that is what context means to me, because running Kubernetes, which specifically clearly groundcover is very focused on, but not just, means running your application in a very infrastructure-aware context of knowing what Kubernetes is doing, making sure that you've set it right, making sure that, in a sense, you're not shooting yourself in the foot with some faulty configurations just because it's a very powerful platform, and you might just get it wrong, right, and not be aware of that. So I think we're very infrastructure non-agnostic, I'd say, kind of being aware of what's happening. And I think that's maybe the next generation of observability tools. And also AWS does a lot of that, right, providing you that parameterial view of what actually goes on with your infrastructure. I think that becomes more and more important as we go into these complex infrastructure orchestration systems like Kubernetes.
Yeah, I love it. Great response. So look, I would love to get into the demo. I want to see what you've got for us, Shahar. But very quickly, from my understanding of groundcover, there's two things that I think really make your solution unique. Number one is the use of eBPF for enabling like zero code instrumentation, easy installation, get started quickly. And number two, that your data doesn't leave AWS. And that's, I think, really unique, that we're not actively streaming all of your telemetry outside of AWS to be ingested and consumed and displayed in another environment. Your data stays in AWS. I don't really understand how this works yet, but I have a feeling I'm going to understand as you go through your demo. Shahar, are you ready to jump into it?
Yeah, let's do it.
Let's do it.
So just before kind of diving to the actual demo, Sai, you touched on one of the major differentiators of groundcover. I think we should kind of just mention that basically the data never leaves your AWS premises, as you mentioned, and the fact is that groundcover is built on an architecture which we call in cloud. We love the name. Maybe it could be more sophisticated, but I kind of stuck from an early stage. So in cloud basically allows us to use that eBPF sensor, collect the data, right? Do all the things we mentioned from the sensor side, but basically ship all this data into a managed backend that stores the logs, metrics, and traces we collect inside your actual AWS premises. The reason it's interesting is, first, it's very privacy, security aware, and kind of we work with different varieties of companies that are concerned about that. But also it kind of fits right into the actual value prop of other managed services that AWS provides, in a sense that if you think about it, why do people go into managed Prometheus, OpenSearch, managed by AWS, and a lot of different technologies like that, is because it offers them the ability to be, one, cost effective, right? They prefer using AWS resources close to home, where they know how to, basically provision storage and compute. And also the fact that they can, reuse this data in different ways. It's known to them. It's transparent. It's their technologies they understand, and they just don't want to manage, right? Because eventually they don't want to take responsibility of their Elastic or Prometheus. So InCloud kind of offers that. We use open source technologies. We use Victoria Metrics and ClickHouse behind the scenes to kind of orchestrate all that, running that in your AWS environment, managing it for you, basically creating the same experience that you might have gotten so far from AWS's managed services that are closer to what you maybe want, right? You want to keep the data close, you want to see it, you want to control it, but not manage it. So I think that's kind of what we're doing, and which is unique.
I can't wait to see it. Let's see it.
Yeah, we're seeing it. So this is groundcover. Jumping to just a sec. Sorry, to share the actual tab. So let me know. Do you guys see that?
We can see it. It's a little small. You might want to zoom in. There we go. You got it.
Yeah,
that works.
that looked like a very complex dependency graph there.
It's actually a small demo environment, so just imagine what we see at customer.
Yeah.
So this is groundcover. Basically, what you're seeing, just starting off with this feature because it kind of catches the eye really quickly to show what eBPF can do. So basically, all that you see here are dependencies being picked up by the eBPF sensor. This is a Kubernetes cluster with a deployment of a demo application, just communicating with with different components. We can see all the different dependencies. We can see the protocols being communicated between this front end kind of module and the other services alongside that. And we can also see the metrics of requests per second, latency, error rate, basically these SLOs, which are very, very hard to collect. If we dive into any of these connections, then we see actual traces. These are picked up by eBPF on the fly as we kind of run the sensor, and it allows us to observe very deeply inside the context of the trace. First of all, what we can see is the full payload and headers of the request, but also the response. So it's very easy to kind of dive down into what actually happened and was passed in the response, with a lot of attributes that kind of depict the trace itself, but also the context, which we mentioned before. First, the context to the Kubernetes layer, the actual container image that we use, which node we were running on, what were the environment variables of the container at the time of the trace, what are the logs that kind of came to be at the time of the actual trace, so you can zoom into a specific log you might be interested in looking into. But also, what was the context of metrics from the infrastructure? So was the container close to its limit? Was the node close to capacity? These are really hard to collect all at once. And we do that with the same eBPF sensor. And that's kind of shows you the power of that technology to move between infrastructure and application really, really quickly.
So Shahar, I've got to share a story with you, because in a role not too long ago, I was an engineer who had to set up tracing for my microservice. And I remember being given a Node.js library and being told, all right, every request that comes in, you have to pick up this response header and put it into your code, and then send that to any requests you make outbound. And I remember thinking, there's got to be a better way to do this. So is there any code instrumentation to get all of this working?
No, none. And it's the interesting thing is, if you look just at the example of all the traces flowing in right now to the eBPF sensor, these traces come from very different technologies, right? So if we just focus on something else, like looking at Mongo traces, we're looking at Mongo clients right now communicating the cluster, and we can actually see the Mongo query and see the response from the server. This required no instrumentation, so it's also language independent and also protocol independent. So we're going to pick up SQL queries to an RDS in AWS. We're going to pick up connections to a remote Kafka or any managed services, SQS, S3, anything that even kind of goes outside of the cluster, including HTTP, gRPC, whatever you guys are using to communicate inside the cluster for APIs. And that's extremely powerful, because eventually you get a coverage out of the box on your entire Kubernetes applications, and suddenly you see things that you didn't see before. It happens to us at any new installation of groundcover.
I mean, this is the magic of observability tool like this, right? Because people really complain that, back in the monolithic days, finding the root cause of an issue in your application was so much easier. You could just tail the logs and see everything from the initial request through all the different components, services in your MVC, SOA-based Java monolith architecture. It was good for tracking down the source of an issue. But with microservices and Kubernetes, that problem became, exponentially harder. More microservices scaled up means you never really know what node it's going to, which pod it's going to, which container, which IP address. So essentially what you're showing here is the ability to find the root cause of an issue that might arise, right?
Yeah, just to show you another small glimpse, if we look at just an example, we're going to dive into that front end piece that we saw before, that service that we looked at the map itself. Then this is how groundcover sees context, right? So we're looking at the specific workload. This is deployed on our cluster. We see a bunch of monitors, this kind of monitoring specific things we think are important to Kubernetes, like pod restarts and kills in this specific infrastructure tab. We also see the availability of the workload over time. So if it crashed or there's any infrastructure event, we would see that here. And also we show you the pods running in this application and their state, the state of the dependency map, and then a bunch of information which is very native to Kubernetes and the infrastructure itself, like pod resources compared to the limits and requests that you've actually set, the node you're running on and its performance, and also interdependencies between applications running on the same node. So you might have some kind of problem. And the next bit is kind of your APM kind of view of what endpoints this service is using inbound and outbound, and what are their metrics. Again, all this is picked up with no code instrumentation. And just to show you as the last bit what Nirmal I talked about in KubeCon of eBPF and how deep it can go. It can also bring you all the way down to network metrics like throughput, and breakdown of the throughput to who you're communicating with, even measuring cross availabilities on communication, which specifically eBPF can do much better than anything else, because it kind of sits there on this junction between infrastructure and application.
And this is a really, I really appreciate you highlighting this, because as our customers got to scale out their solutions, their applications, they start to go beyond just one AZ, right? The typical architectural best practices is to at least have 3 AZs for your compute nodes in a EKS cluster, and then also multiple clusters at a time that have their own dependencies. And your applications could have dependencies with other applications in a completely different cluster somewhere, or a different AZ, or and at a basic level, Kubernetes doesn't necessarily know or is aware of where that, what the state of your application is to that underlying infrastructure. And can you kind of go into how groundcover kind of connects those dots with the infrastructure and where that workload is, to kind of give that holistic view?
Yeah, so basically you just see this specific workload. You can also jump between those different workloads and look at them from very different aspects, right? You can start from looking at them from an infrastructure perspective, and this is a 2-node cluster, but you can actually look at the nodes themselves and look at the actual pods that run on these nodes, and start from there. Kind of,
so this might be a view for like a platform engineer or an SRE.
Yeah.
That's responsible for the overall cluster health and try to do some capacity planning, etc.
True, but they can move really quickly in between, because we understand everything is connected, right? So they can see that some pod behavior is looking off, jump to events from the infrastructure that might indicate some problem, and at some point they might want to just say, this workload is interesting. I might want to jump into say what's going on with that and how this is behaving, and just jumping to that workload and starting the drill from, maybe look at the logs, emitted in this workload, and, what's happening from an infrastructure context on the workload itself, and what endpoints is it using. So it's really easy to kind of move in between. And I think that specifically in Kubernetes, even if you're an infrastructure engineer, you might want to be able to kind of expand your reach a bit, right? Look at logs, look at metrics, look at custom metrics maybe, and maybe look at an endpoint that is misbehaving before going to dev, right? Before trying to, grab on the developer itself that wrote the code. And we're kind of trying to create that feeling, using the sensor that kind of picks it all up.
At the beginning, when you were clicking on that overall dependency kind of network view, you mentioned like SLI, SLO, I believe. Can you kind of dig into that a little bit? How are those defined? Because that's kind of what I was alluding to with respect to working backwards, right? Finding what matters to that end user or your customer. That's how you define the service level indicator or the service level objectives for that indicator. So what does that look like in groundcover?
So just to show you a quick view of what we call the API catalog, basically it's exactly what you described. It's kind of these, endpoint catalog, whether it's HTTP or Mongo or Kafka or Postgres or whatever. Basically just showing you what is going on inside the cluster, what endpoints are being used, and what are these SLOs, or basically, red signals. How do they look like? And basically what groundcover does with eBPF, again, it's kind of a logic on top of the sensor, is collecting all the traffic and all the communications and then aggregating them into what we think are endpoints. So for HTTP, for example, it might be, stripping some GUID or some, running number that doesn't really depicts an endpoint, and in this case you can see the /product asterisk just saying this specific endpoint is being hit. It's unencrypted, just FYI. This is the client generating it, and you can see the request per second, error rate, and latency. And these are built on that endpoint for that container, with that URI. And looking through all that, you can suddenly do stuff like sort by latency or anything they want to do, and pick up on endpoints that might kind of behave differently, even from a performance perspective. Even if their error rate seems right, then you can easily jump into problems. It gets really interesting. This is just a small demo, but it gets even more interesting when it comes to SQL queries, for example. This is a managed RDS. I don't know if you guys can see that, but this is a managed RDS in AWS outside of the cluster. We can see 3 different queries just from this demo client, and we can sort by latency and really quickly reach the slowest one. And when we do, we actually get examples of that. Basically, we can see the query, we can see the actual response from the server, and this is really powerful when you're trying to figure out what just went wrong, right? So kind of an interesting example of how endpoints or SLOs can serve you when you're also kind of investigating performance.
Yeah, can you click on the container info real quick?
Yep.
Yeah, so again, Kubernetes out of the box isn't going to tell you like this SQL query is running from this container, right? Like, so how does this get populated? Like, where is this information coming from, and how is that correlation happening?
So what's cool about eBPF is that eBPF isn't really aware of all that, right? eBPF, is basically a Linux-based. It knows processes, it knows sockets. That's the language it speaks, right? It doesn't know Kubernetes. Eventually, Kubernetes is, a beautiful orchestration running on top of these Linux VMs, right? That eBPF kind of populates. So basically, groundcover ties both ends from, these are very different and far away endpoints. One of them being eBPF that sees these processes and sockets, and the other being the Kubernetes API that kind of creates that full hierarchy behind Kubernetes. So eventually we figure out for that process, who is that container? For that remote port, who is that actual remote pod? And what is that? What is its name? What is its workload? What is its namespace? And kind of populate all that on top of the information, which is very low level collected from eBPF. Because eventually, once you do that, then automatically the user gets, that indulging experience of just seeing the actual Kubernetes data as they know it, right? They know the workload names, they know the namespaces, they know the container names. And that's what we're trying to do here, even though the data is being collected even lower than the Kubernetes layer. So eBPF kind of, allows us to collect the data. We just need to correlate it right using the Kubernetes API, and that's why we're very Kubernetes centric, because it allows us to be very frictionless around that. Even though we're moving to other instances, like groundcover is about to support EC2, for example, it will require a bit more help from the customer, right? Of labeling and tagging and helping us a bit understand what is that workload we're just monitoring right now on that remote EC2. Kubernetes does it for us in a sense.
Shahar, we just leaked the credentials to your Postgres database on RDS. We may want to change that.
Thank God it's the demo.
Luckily, a demo environment, folks. Don't get too excited. We actually got a great question in chat that I want to make sure we cover here from Kritzy TKO. Quick question. I'm migrating a portion of on-premises multi-Kubernetes clusters to EKS. What's the main difference between using something like Kube Prometheus Stack, which, if I understand correctly, is just the open source Helm chart that installs Prometheus, Grafana, and a few other components to run yourself in Kubernetes, compared to groundcover?
So great question. I think that anything that is, Prometheus stack, like, metric servers or anything that basically kind of deploys exporters across your stack is a great idea to kind of use. The thing is that it relies on metrics being exposed by your different endpoints, running your node exporter, collecting metrics from your node, or anything that can be collected from your service mesh or from your exposed containers, or anything that is already kind of being exposed by your application. That's great. That's a great start. But eBPF basically allows you to go deeper into places that first you didn't kind of manage to instrument or expose metrics to. And these are usually the applications themselves, right? So kind of taking the infrastructure metrics that in some cases you can definitely get from these Prometheus stacks, but also getting to that, latency metric on that API and tying that together. That requires a lot of thinking from the R&D team of, okay, that application, what do I actually need to expose? What metric do I need to create to make sure that I have both? And eBPF kind of take the relief on that. On the other end, we do make sure that we replace these exporters in a sense that you don't need both, right? You don't need another log collector or another exporter alongside groundcover, because we do that for you. We scrape custom metrics, we do whatever is needed, because these are definitely an important piece of the puzzle. Just that eBPF can go a bit further than that.
Got it. So, Prometheus will get you a lot of these great metrics from the system itself. It helps you monitor things that Kubernetes is able to manage. But eBPF being, hooked into the kernel, you're getting deeper level of data. So basically what you just had demoed, showing us the power of what eBPF can do over Prometheus, right?
Exactly. Specifically application things and API or APM insights are really, really hard to get from without working hard inside the code.
Yeah, makes sense. Shahar, I've got a hard question for you. In the docs that you've got, it says groundcover is a full stack solution. In fact, I did Control F on the page, and Kubernetes was only mentioned one time. What about customers in a realistic environment that have assets running in Kubernetes, outside of Kubernetes, on premises, in the cloud? Maybe they've got some Lambda functions, some EC2 nodes running. How do they get all this into this ecosystem?
So first of all, the answer is twofold. One, groundcover is starting from Kubernetes, is Kubernetes centric, but we are moving to run the sensor in more and more places. As I mentioned, EC2 is coming up, and then EKS is kind of nominated as our next support, because we do believe that where we can run the sensor, we can definitely do much more. We can integrate the data, as you saw. We can create these contexts. We can be much more aware of what's going on. But even if we do that, we still can't run the sensor anywhere. There's limitations to eBPF, like Lambda functions, like Fargate nodes, which will eventually maybe be solved by the community. But there's still a gap where you can't run eBPF anywhere. Windows servers, right? It will eventually happen in some kind of patches where eBPF as a sensor cannot run. And then groundcover and our in-cloud basically is built to be very friendly to integrations we believe in, right? For example, we use a Prometheus friendly or Prometheus compatible database. So we will support scraping Prometheus from your remote instances, or support remote writes, so you can pour that data in. We support integrations with any log collector like FluentBit. So if you have something running remotely, you can push it into groundcover. We support native integration with Firehose, so you can basically flow your CloudWatch logs into groundcover, and then kind of cover all of your AWS infrastructure at once. So we definitely kind of support integrations to kind of make you get the full experience, but we do want to expand our reach to where the sensor can actually run, where we can actually run, because it still provides that extra frictionless edge of just creating the full image of things really quickly, and an integration will always be a little bit more limited, right? A little less context aware.
Got it. That makes a lot of sense. Okay, one of the things that we covered before was that your data never leaves AWS, doesn't have to potentially leave. So where is it hosted, and how, as a customer, are you paying for the resources to run all of these observability tools? And notably, when you're scaling from, let's say, a small dev test environment to maybe tomorrow you scale up to thousands of pods across multiple clusters in your AWS environment, who handles that scale for you?
So basically, that's the cool thing. First of all, where it runs, groundcover is EKS pure. Then our in-cloud also runs on EKS. So basically, what happens when we monitor Kubernetes is that we create kind of a pure Kubernetes stack. We're monitoring Kubernetes with a backend that stores the data on Kubernetes on EKS. And the experience is basically running on your Kubernetes or on your AWS account in a sub account you create for groundcover's in-cloud. Basically, we get a cross-account role to be very practical, and we have an automated control plane that manages and provisions that backend, that EKS cluster, with those stateful sets that basically store the logs, metrics, and traces that are collected by the sensor. So basically, we don't have any access to the application clusters where the sensors run, where your applications run. but we do have access to provision, control, scale up and down, back up, support disaster recovery, and anything that you would expect from an observability platform on that EKS in cloud running in that sub account. So we scale it up for you. So if you kind of 10x the load, we're going to make sure that in cloud, that EKS cluster, inflates up to support that load and take that charges. And just like running Prometheus or running Grafana or running anything self-hosted, you basically pick up the payment from in front of AWS. But that's where customers love it, because they already work with AWS. They know how to procure storage and compute in a way they know it. It can be either through their EDP or whatever, but it allows them to kind of use their already existing methods of working with AWS storage and compute and networking in their in-cloud. If they want to provision security policies on top of groundcover like they do in other AWS areas, they can do that on their in-cloud instance, because it's their account, it's their EKS environment, and it provides kind of a different mindset into what is mine and what is the vendor's, right? Suddenly there's a blurry line there. So that's kind of how we operate.
Excellent.
I like it. I like that a lot. It provides a lot of flexibility to customers in terms of control, right? And making sure that it's kind of being a more transparent to the end customer and allowing them to make the decisions about what they want to retain in terms of telemetry data. And instead of kind of just doing I'm just going to collect everything all the time, like puts it kind of front and center, like you're paying for what you're using.
And I think it's a transparency of the cost. We tell the customer exactly where it's running, what resources are running to power this. You have to see it. It's in your account. The data stays there, which in itself is a cost-effective approach. This is, I think, one of those things why I was excited to have you, Shahar, is that this is refreshingly new. This is different. I don't think we've seen something like this before. It's like this hybrid SaaS solution where it behaves like a SaaS, but it's actually running in your own AWS account, in your own environments, leveraging the scalability of EKS to make sure that your observability stack always, is available, it's resilient, it's responsive, etc.
Exactly.
Really unique, really cool stuff.
I also like that you're running this on EKS in the customer's account, which I would assume means that you're also dog fooding and using your own tools, and that kind of alignment is, that's always a good thing, I think, because
you would be exactly correct. Basically, we run a kind of a shrink down version of groundcover because we don't want to collect like traces and stuff like that from things being flown into the database. We read into the database itself, so it's kind of a shrink down version of the sensor, but we actually monitor the in-cloud with groundcover because that's what we think works best, right? It's driven from EKS. We want to be aware of the infrastructure. We want to make sure that the databases kind of work with the infrastructure in tandem. So yeah, eBPF works great there as well, and we actually dog food ourselves all the way throughout the chain. So yeah,
very cool.
Very cool. All right, so getting ready to close out our episode here. Last chance, folks, if you have any questions for our awesome guests here today, Nirmal or Shahar, while they're live, it's your chance to drop some questions in the chat. Shahar, I've got a question for you about the future of groundcover, and what are you most excited about at groundcover today?
I think we're very, very excited to see how users from both open source and the vendor domain are kind of interested in that as they transition to more modern stacks like Kubernetes. And basically, we're gonna work really hard. The future for groundcover is working really hard to create that platform move, because we believe that regardless of eBPF, which is huge and cool and interesting, customers need log management, and they need different things which might not be that related to eBPF that can provide that extra tracing layer. So providing all of that in a very modern and cost-effective ways on our in-cloud together with eBPF all across the different verticals of what observability is, that's kind of what we're focused on, and that's kind of the direction where groundcover is going. So it's always a bit more than just eBPF, and we're expanding in many different directions. So kind of we're excited about that.
Excellent. Nirmal, closing question for you. You're you're a leader within AWS. You oversee our massive community of container-based solutions architects, but you're also prolific externally. How can people get in touch with you, get involved? I know we have upcoming events and that kind of thing. What's the best way for our viewers to get involved with observability at AWS?
So first of all, the blog post that you posted, we did a joint blog post with groundcover around eBPF specifically, and there's a lot of awesome links there. That's one place to start with respect to just eBPF and understanding that technology, because it's not only for observability, but its impact. There's impact from eBPF with respect to security, network and service mesh, and I'm sure there's a lot of other areas that we have yet to discover or yet to implement. So if you're out there, you're curious about what eBPF is, what it could be used for, some of the open source projects. Check out that blog post that's in the chat right now, I think, right, Sai?
Yep.
Awesome. And then for myself, the AWS Containers blog, we have lots of content around all this, different topics every week. We publish, and then right here, right, Sai? Containers on the Couch. Hopefully we'll see each other more often here. Maybe I'll do a little bit of self-endorsement there, but hopefully this went well, and I can come back to your lovely couch, Sai. But in general, you can find me on LinkedIn. I can post my link on there if you have it, but connect with me on LinkedIn. I also do my own live stream every week with Brett Fisher on Brett Fisher's podcast, where we cover cloud native, DevOps, and Docker. And actually, groundcover Shahar was on that 2 weeks ago, I think, 2 or 3 weeks ago.
Yeah, it was great, but you weren't.
Unfortunately, I was speaking at DC Summit. So also, you can catch me at events, and I'll likely be, and I know Sai and I we're working on this, but we'll likely be at Salt Lake City for KubeCon. So if you want to see us in the flesh, in real life, as the kids say, see us in Salt Lake City, and then absolutely at reInvent later this year, and maybe some other events in between. We'll see. Shahar, are you going to be at KubeCon this year, North America?
Yeah, KubeCon and reInvent are both big events for us. So groundcover is going to be there full-fledged for sure.
Awesome. So that sounds like if you have a question about this, about eBPF observability, catch us in Salt Lake City and in Las Vegas later this year for sure.
Exactly.
Awesome. Well, thank you both again so much for agreeing to come on the couch, Containers from the Couch. This was honestly a really exciting episode. Folks that are watching at home, be sure to like and subscribe to watch more episodes like this in the future. Next Thursday, we're planning to do another episode, so be sure to tune in for that one. Thanks again, folks. Catch you next time.